Have you ever wondered what it would actually take to run a massive, world-class artificial intelligence entirely on your own desk?
Like completely disconnected from the internet.
Yeah, exactly. Just
Yeah.
you, a metal box, and a brain with billions of parameters, completely untethered from corporate cloud servers.
It sounds like science fiction, honestly. But it's actually happening right now.
It really is, and that is what today's deep dive is all about. We are exploring the GMKtec EVO-X2. It's this high-capacity mini PC.
Yeah, and to figure out what this machine actually represents, we're pulling from the official technical specifications, of course,
Right.
but we're pairing that with a truly fascinating stack of deeply technical, hands-on user reviews. We're looking at notes from buyers who are pushing this little machine to its absolute breaking point.
So our mission today is to kind of cut through all the marketing jargon. We need to determine if this $3,300 lunchbox-sized computer is genuinely the ultimate home lab for AI developers.
Or if it's just, an overpriced, overheating, tinkering project. Because it really asks a lot of the user.
Okay, let's unpack this for you, the listener. We're looking at a computer the size of a lunchbox that claims to rival massive server racks. How is that even possible?
Well, to understand the hype, we first have to look at the hardware architecture. The brain here is the AMD Ryzen AI Max plus 395 processor.
Right, which has 16 cores, 32 threads, and it boosts up to 5.1 gigahertz.
Exactly. And it's paired with a massive integrated GPU, the Radeon 8060S. It has 40 compute units.
I mean, I look at those numbers and they're impressive, sure. But they don't seem like they should be, shattering enterprise data center records. What's the secret sauce here?
What's fascinating here is that the processor isn't actually the magic ingredient. The real star of the show, the thing making the AI community lose its collective mind, is the memory.
The RAM?
Yes.
Oh.
This machine features 128 gigabytes of LPDDR5X RAM, and it is soldered directly onto the board.
Okay, I want to use an analogy to help visualize why that specific design choice is so revolutionary.
Yeah.
Think of a high-end gaming graphics card, like an RTX 4090, as a Ferrari.
Okay, I like that.
It's blisteringly fast. But a Ferrari only has a tiny trunk for its luggage, right? In the computer world, that trunk is the video RAM, or VRAM.
Right, which usually caps out around 24 gigabytes on consumer cards.
Exactly. But this mini PC, the EVO-X2, is essentially a cargo truck. It might not win a drag race against that Ferrari RTX 4090, but it has a massive warehouse for data.
Yeah, and that distinction is everything for large language models.
Yeah.
Because LLMs don't just need raw speed, they're entirely bottlenecked by memory capacity.
Because they have to load so much data just to turn on, right?
Exactly. In a traditional setup, the CPU and the GPU have separate pools of memory. They have to constantly shuttle data back and forth down a digital highway. It's incredibly inefficient.
But the EVO-X2 uses unified memory. The CPU and the GPU share that massive 128 gigabyte warehouse.
Right, so there's no digital highway. The graphics unit just reaches directly into that colossal pool. This allows users to load models that would otherwise require multiple expensive, dedicated GPUs linked together.
Which costs an absolute fortune.
Yeah, tens of thousands of dollars.
Okay, so the warehouse is huge. But wait, I have to push back here, because as I read through these user reviews, a really frustrating theme kept coming up.
Oh, the software nightmare.
Yes. If a user pays $3,300 for 128 gigabytes of RAM, why are the reviews saying they have to actively fight the computer to actually use it?
It is the starkest contrast with this device. You have this premium server-grade hardware, but it's crippled by GMKtec's consumer-grade software support.
It's wild. Like, buyers are complaining that essential BIOS updates and drivers are literally hosted on a public Google Drive.
Yeah, I saw that.
Users are clicking the link to update their brand new machine and getting an error that says, download quota has been exceeded.
It's just absurd. The software struggle goes way deeper than Google Drive links. The real battle is with Windows 11.
Right, because Windows doesn't understand what to do with that much unified memory.
Exactly. The default BIOS artificially caps the video RAM allocation at just 48 gigabytes.
Which completely defeats the purpose of buying the 128 gigabyte model.
It really does. So users have to repeatedly hit the escape key on boot, force their way into the BIOS, and manually command it to allocate 96 gigabytes.
But even then, Windows still fights it, right?
Yeah, it crashes.
Yeah.
Which is why the power users are abandoning Windows entirely. They're doing what we can call the Linux hack.
Okay, let's talk about the Linux hack, because reviewers like Mike and Amazon Customer detail this grueling process.
Yeah, they completely wipe Windows. They install a Linux distro like Ubuntu or Debian.
And then they have to start writing code into the core bootloader. Mike mentioned a specific grub kernel command he had to use. It was amggbu.gte size 126976.
Right, the graphics translation table size.
Can you explain what that actually does? Why is that line of code the magic key to the warehouse?
Think of the translation table as an index of a book or a map of that warehouse you mentioned. The GPU needs that map to know where every piece of data is stored.
Okay.
By default, the operating system keeps that map pretty small. So by typing in that specific number, the user is tricking the Linux kernel. They're expanding the map.
So the GPU can suddenly see and use up to 124 gigabytes of the system RAM as unified video memory.
Exactly. It's not a plug-and-play appliance. It requires serious technical chops. You are basically acting as a system administrator to make this thing work.
But the reviews all agree that if you are willing to tune the system, the reward is a machine that just punches absurdly above its weight class.
Oh, without a doubt.
So once these users successfully hack their way into the warehouse, what exactly are they doing with it?
Well, they're running staggering models. We're talking about the Qwen 235B.
A 235 billion parameter model on a desk? That is just wow.
Yeah, and the OpenNUF TOS 120B model. And they're getting incredible speed breakthroughs, too.
Right, because of the software engine switch.
Yes.
Yeah.
Initially, users were running these on the Vulkan engine, getting maybe 5 to 10 tokens per second.
Which is, for the listener, roughly the speed of a fast human typist. Functional, but not crazy fast.
But then the community figured out how to compile AMD's ROCm engine specifically for this hardware.
And the speeds exploded. Reviewer Edward Lee reported achieving 36 to 40 tokens per second on a 120 billion parameter model.
Which significantly faster than you can read. It's pouring text onto the screen.
And here's where it gets really interesting. Because the speed was so intense, the AI actually hallucinated.
Oh, this story is incredible.
Yeah. Edward asked the AI to evaluate its own performance. It looked at its speed, compared it to consumer hardware, and literally concluded that the machine it was running on was impossible.
It hallucinated that the computer didn't exist.
Exactly. But Edward didn't stop there. He decided to really push the cognitive limits. He ran a stress test on the 235 billion parameter model that reads like a sci-fi psychological thriller.
He was pushing the AI's context window, right, as short-term memory.
Right. He pushed it so hard that the AI just buckled under the cognitive load. It completely lost its grip on language and started endlessly outputting the letter G. Just G over and over.
Yeah, the attention mechanism degraded because the memory got too stuffed.
Yeah. So to fix it, Edward had to basically act as an AI psychologist. He went into the back end and tweaked the evaluation batch size, dropping it from 512 down to 4.
Which forces the AI to sip the data instead of gulping it down. It processes information in tiny increments so it doesn't crash.
He also tweaked the map settings, and once he stabilized this fragile, hallucinating brain, he fed it a massively complex prompt.
The spaceship crew prompt.
Yes. He told the AI that a spaceship crew had woken up from suspended animation. But the ship's internal AI system thought it was still in the past.
Because its atomic clock had been destroyed by orbital shrapnel. I love this prompt.
Right, so the crew has to use an improvised clock to sync the AI's hallucinations to the present. And they eventually have to search for a pulsar as a real-world time reference.
It's so wonderfully meta. He is using a story about a broken, hallucinating AI to test a real AI that is literally on the verge of hallucinating.
And he's doing all of this deep psychological tuning on a machine sitting next to his coffee mug. It really shows how intimate local AI is. You are the operator keeping the machine balanced.
But, running those massive stress tests takes a serious physical toll on such a tiny machine.
Right. Let's get into the physical reality of this, because the marketing claims a quiet mode of just 35 decibels with its triple cooling fans.
Yeah, they paint a picture of a silent little cube. But the reality is completely different.
A reviewer named Jeepin reported severe thermal throttling. Like, the CPU was hitting 105 degrees Celsius.
Water boils at 100 degrees. That is a terrifying amount of heat inside a tiny metal box.
And because of that heat, the fans were just constantly cycling. Jeepin said they were loud enough to cover up the noise of other machines running in the same room.
It just shows you can't outsmart the physics of heat dissipation.
And the heat seems to cause other hardware quirks, too, like the solid-state drives. The EVO-X2 has PCIe 4.0 slots. Jeepin put in top-tier Samsung drives rated for 7,000 megabytes a second.
But they were maxing out at 6,000 megabytes per second. The physical traces on the motherboard just couldn't handle the absolute peak throughput.
And then there's that incredibly frustrating monitor bug.
Oh, the DisplayPort issue.
Yeah, if the monitor goes to sleep, the computer panics. Every 10 seconds, it physically disconnects and reconnects the monitor. You just hear the Windows chime over and over.
Just endlessly chiming. It's maddening.
Jeepin tried everything, reinstalling the OS, tweaking BIOS power settings, and nothing fixed it. It's a huge reality check.
If we connect this to the bigger picture, it perfectly encapsulates the current era of local AI.
How so?
We are taking server-grade workloads, things meant for climate-controlled data centers, and cramming them into consumer desktop boxes.
Right.
The hardware is physically straining under the weight of the math. The fans scream, the silicon boils, and the software splinters.
But the fact that it works at all is just a miracle, a messy, loud miracle.
Absolutely.
And hey, if wrestling with Linux kernels, tweaking batch sizes, and building a massive unified memory warehouse sounds like your ideal weekend project, we have a quick reminder for you.
Go for it.
At the end, if you like the content, please subscribe, Smart Shop US, and share for more. You can like and share, and if you'd like to buy this product, find the link in the description.
It's definitely not for the faint of heart. But for those willing to put in the work, it's incredible.
So to wrap this up, we are rapidly entering an era where an individual can house a cargo truck of human knowledge right on their desk, entirely untethered from corporate servers or the internet.
It really makes you wonder where this is all heading.
It does. It leaves us with something profound to ponder. What happens to society when anyone, anywhere, can have an uncensored 235 billion parameter brain sitting right next to their keyboard? A brain capable of generating endless realities, code, and ideas in total privacy. The warehouse is built, we just have to decide what to put inside it.